C++ Club UK, 15th of August 2019. Timo Damler published his Cologne trip report. He covers several topics. First of all, no contracts in C++ 20. Timo writes, let's address the big news first. We removed contracts from C++ 20. He writes, we then had over a dozen papers on the table in UG pointing out those and other issues and suggesting different mutually incompatible solutions. Some of them were minor fixes, others were more significant redesigns of contracts. One of them was a significant redesign, and the committee ultimately agreed that it was too late in the C++ 20 release cycle to approve such a redesign now. An evening sessions with the authors of contract-related papers was convened to figure out a way forward. I was in the room, Timo writes. In this meeting we talked in great detail about different use cases of contracts and learned that we don't actually yet understand each other's use cases well enough to be able to make any decision confidently. This realization then led to the only possible decision. We unanimously agreed to remove contracts from C++ 20. He then writes about forming of SG21, a new contract study group, chaired by John Spicer. And then he says, I think this is a very positive outcome of Cologne. Work on collecting, describing and categorizing the use cases of contracts is already underway. Timo expects to participate in SG21 to help with that effort. He has his own interest in the contracts. He has a proposal in the race, P1774, proposing STD assume, and he hopes to get it into C++ 23. Timo then writes about concepts, modules, coroutines, and operator spaceship. He says those are doing well. Some of them needed only minor fixes, and all are good to go. Concepts received a larger change. We voted in Cologne to rename all C++ 20 concepts from Pascal case to Snake case, to be consistent with all other names in the C++ standard library. He then says, this led to an interesting situation where many concepts have a corresponding type trait or meta function starting with is underscore. For example, stud copy constructible is now the new concept, and stud is copy constructible is the corresponding type trait, which has been around since C++ 11. As contracts get used more and more, these meta functions there will be fewer and fewer reasons to use them. Timo then writes about formatting, about stud format library, multi-threading and synchronization. The new C++ 20 synchronization library gives us semaphores, latches, barriers, and lots of other useful synchronization and thread coordination facilities. Timo then writes, this library is pure gold for people who write multi-threaded high-performance software. And we also got a stop token and a JThread, which automatically joins upon destruction. Timo writes about things that didn't make it into C++ 20, like, for example, stud flat set and stud flat map, stud any invocable, which is a useful alternative to stud function. There's no compile time for ... and there's no fixes for the C++ object model, which would have provided a legal way to achieve some popular type punning style tricks that today have undefined behavior. Basically, it allows you to allocate memory and then treat that memory as if an object has already been created there. So, like here, for example, you call malloc, which gives you the memory of the size of an object, and then you cast it to an object, and you if that paper were to be accepted, you would instantly have a capability to access that memory as if there was an object in it. Back to Timo's blog post. He then writes about CTAD improvements. Not all of them were accepted as he was proposing them. We got CTAD for aggregates and alias templates, but not for inherited constructors in C++20. Timo then writes about audio, stud audio proposal that he put a lot of work in. They got some really interesting feedback from Apple audio engineers. They are using stud error code following the stud file system example. Some things he writes we don't know yet how to solve, such as how to support 24-bit integers and reversed Indianness integers as a sample format, which is a thing in some native audio APIs, but unfortunately not something the C++ standard really supports. In parallel, he says we will propose our implementation of stud audio for inclusion into Boost as Boost Audio, so you all can get your hands on a proper reviewed and tested implementation of stud audio as soon as possible. The next update about committee work will come after Belfast in November 2019. GCC 9.2 released. There's a colorful diagnostic that highlights the actual place where error happened. Like here, for example, in C++, diagnostic output, you get pointed to the actual location of the error even with the line numbers on the left. Lots of nice colors. There's lots of improvements into the runtime library. There's now support for D in GCC, and the version 9.2 looks like it's all about bug fixes. Ben Dean posted on his blog the article called "Remember the Vasa," or I'm not pronouncing that French sentence, but I'm told it means times change and yet they stay the same. One quote from his article is, "C++ is growing, change can be daunting, but I think we're going to be fine, and when one day a specific little hammer is just the right tool for the task at hand, I'll be thankful that someone added that hammer to my toolbox." And this is in reference to a quote from Bjarne Stroustrup's article, "The Design and Evolution of C++, where he mentions that Remember the Vasa became a popular cautionary tale, but then he says C++ was designed to provide a toolset for professionals, and complaining that there are too many features is like the layman looking into an upholsterer's tool chest and complaining that there couldn't possibly be a need for all those little hammers." It's nice to read a positive article about C++ once in a while. There is apparently a popular and widely used operating system called VxWorks, and it's a real-time operating system from a company called Windriver. It powers more than 2 billion devices. It powers all the space robots, all the robots on Mars are powered by, are powered by VxWorks. Also, lots of medical equipment is powered by it, and apparently the current version uses Clang and C++14, so it's really nice to see that such a widely used operating system supports a pretty recent C++ standard. Vittorio Romeo posted an article called "Fixing C++ with Epochs." The intro to this article, I think, is aimed at Bjarne Stroustrup. Vittorio says, imagine that you have been designing a programming language for over 30 years and that is gradually become widely used across the globe. Some of the decisions you made at the beginning were excellent and contributed to the success of your project. Some others, however, were not the best. Over the years, you and your users realized that the world would have been a better place if those choices you made eons ago were slightly different. He then writes, you try removing the most dangerous and least used aspects of the language, and while their dismissal is highly successful, some users will undoubtedly be hindered by it. Vittorio then writes, there seems to be no way out until you stumble on this post. Its author makes an incredible claim, worthy of the worst clickbait advertisement. What if I told you that I could fix all your problems? Even better, what if I told you that backwards compatibility will never be broken, and that migration to newer versions of your language could be automated? At this point you immediately think that this guy must be insane. Then he says, also someone already did it and it works. As you might have suspected, this is about Rust. Rust has a feature called additions. And Vittorio thinks that the same solution could be applied to C++. So what are Rust additions? Every 2 or 3 years we'll be producing a new edition of Rust. It's a quote from the Rust website. Each edition brings together the features that have landed into a clear package with fully updated documentation and tooling. When a new edition becomes available in the compiler, crates, which are Rust libraries, Rust packages rather, must explicitly opt in to it to take full advantage. This opt-in enables editions to contain incompatible changes, like adding a new keyword that might conflict with identifiers in code, or turning warnings into errors. A Rust compiler will support all editions that existed prior to the compiler's release, and can link crates of any supported editions together. Edition changes only affect the way the compiler initially passes the code. Editions allow designers to make breaking changes, and since they are opt-in, their code is backwards compatible with the existing editions. Automatic migration from an older edition to a new one is often possible. It's possible because Rust is module-based and doesn't support textual inclusion like C++ include preprocessor statement. Vittorio's goal is to convince the C++ committee members that we need an equivalent of Rust editions in C++, and that it's possible to do, and the key to success is the introduction of modules. Since modules are now self-contained units that are isolated from preprocessor macros and textual inclusion, we could have a module-level epoch switch. We could finally improve the safety and expressiveness of the language, fix many constructs that cause frustration and bugs, like std initializer list, he says, achieve a truly uniform initialization syntax, remove older features, safely introduce new keywords, enforce core guidelines in the language itself. There could be even more drastic changes, like make most entities const by default, make types and functions no discard by default, enforce one declaration style like almost always auto or trailing return types, make explicit the default, and introduce an implicit keyword, get rid of dangerous constructs that only exist to maintain C compatibility, or introduce unsafe blocks where they are required to live. The 3 reasons he lists why we're not doing it at the moment are: first, modules are brand new and we still need to gain experience. Second, nobody has formally proposed something like C++ epochs. And third, many veterans in the committee are opposed to the idea. But the main obstacle, according to Vittorio, is number 3. He informally floated the idea of epochs around in the WG21 Jacksonville 2018 meeting, and it was met with heavy resistance. He then lists the concerns that he received back then and provides replies to them. The first concern was introducing module-level syntax switches would lead to the creation of many dialects. He then says, this is a complete misunderstanding of what I'm proposing here. First of all, there would be a single switch, not many coexisting knobs. The switch would allow people to choose between language epochs that are linearly ordered chronologically, no forks or branches. The Standards Committee will still be in charge of deciding when to create a new epoch and in charge of its contents, and breaking changes would not be made lightly. There is absolutely zero risk, he says, of creating many different dialects here. The second concern was module-level switches would lead to community fragmentation. Vittorio replies to that this is again a misunderstanding. This fragmentation would not be any worse than we already have today. Like some people can use C++14, some can use C++17, so some are not allowed to use exceptions and some others are. Adding epochs would not change that situation, for the worse I presume. If every standard introduces a single new epoch, then people will have to opt in to the new standard or not, which is exactly what happens today. Finally, epochs are not going to radically change what C++ is. An epoch might introduce small syntactical changes and safer defaults, but it would not be a different language by any means. And the third concern was module-level switches would make the language more complicated. Vittorio says that it's exactly the opposite. Language rules could be greatly simplified in newer epochs, and many obsolete dangerous constructs could be completely removed. The next concern was module-level switches would make the lives of compiler developers even harder. Vittorio agrees that there's some truth in that, but in one way or another, he says, all remarkable features make the lives of compiler developers harder. If anything, thanks to Rust's experience, we have proof that module-level switches can be implemented and that they work. And the last concern is introducing module-level switches would create a schism similar to Python 2 and Python 3. Again, he says this is a misunderstanding. Python 2 code is not compatible with Python 3 code. Code written in a previous C++ epoch would be compatible with code written in a newer one. Following this article, there was a Reddit discussion, and most people in that discussion were replying with praise and mostly were agreeing with Vittorio's idea. Some even said that C++ will wither away if it doesn't evolve. There's lots of agreement in the thread. Some interesting information about how this works in Rust. The user Alonso says, in Rust the addition only affects lexing. The intermediate representation is the same for all additions. There is another thread which explains how this is done in more detail. There's a post towards the end of the second thread. Find it. Sean Middleditch explains that what Rust frontend does is to compile to MIR, which stands for Mid-Level Intermediate Representation. MIR is much higher level than low-level intermediate representation and has a good deal of knowledge of Rust semantics and information. Effectively, MIR is the heart of Rust. The Rust syntax grammar is just a bunch of sugar to easily produce MIR. Since every edition of Rust must produce MIR, that enforces that all edition upgrades are backwards compatible in the core of the language to a reasonable degree. This is how Rust does it, and this is why editions are backwards compatible and can be linked together. Let's see if that idea is floated again in the next C++ committee meeting. Someone posted on Reddit, and the title is, "Should not exceptions be finally deprecated?" we're not going to go there, it's pointless, but I just wanted to highlight one of the first sentences of that post, which says, "I have been programming in C++ for a long time, but I still do not understand how to use exceptions." And naturally, in this case, when you don't understand something, that feature must be deprecated. Some logic. Arthur O'Dwyer created a C++ acronym glossary on his website. It's a fantastically useful resource where every acronym is explained in detail, including code examples and links to the appropriate papers. It's a really useful resource that deserves bookmarking for any C++ developer. We already had a glossary at the C++ reference website, but it was quite short. There were links to the appropriate features and explanations, but no code examples directly in the glossary. So Arthur O'Dwyer's version is much more useful and complete. I found an interesting abbreviation on this website, which was introduced by Bjarne Strostrup and others in an article called "Minimizing Dependencies with Engineer Classes for Faster and Smaller Programs," where they introduce and use the abbreviation SCARY throughout the paper, which is a good troll, as this abbreviation is a bit stretched. It means seemingly erroneous, appearing constrained by conflicting generic parameters, but actually works with the right implementation unconstrained by the conflict due to minimized dependencies. Right. A new Visual Studio preview is out and it has some productivity improvements. There is new default semantic colorization if you use semantic highlighting, semantic colors. They are really useful to visually track variables throughout the code and other names like functions, class names. You get slightly different color hues for the same variable, not just the same variable type or keyword, but say, for example, a function argument here is colored slightly differently than a function argument of another function, and globals are colored slightly different than member variables. So this helps code comprehension. And just as a side, I like light editor themes because they're more readable. There is a new feature that is called template argument filtering in call stack window. Previously, when you had a call stack, you would get lots of template noise that would prevent you from seeing the entire type in a row because it wouldn't fit in a column. But if you toggle this new feature, Visual Studio collapses all the template parameters so that you can see more information about each frame. The third new feature is IntelliCode on by default. IntelliCode is the new IntelliSense, which is powered by machine learning, and it provides autocompletions that are more relevant to your code and to the code you complete that comes from libraries you use. Free book alert. C++ parallel programming with threading building blocks. The links to PDF and EPUB formats on the Springer website are provided. Threading building blocks is a production-ready, high-quality threading library that's been tested over and over again and is a base of parallel STL implementation. I think it's in Visual C++. Sean Parent has a post on his blog called "Stop Using Out Arguments." I don't think it's a particularly new post, but it's still relevant. In the post, Sean argues that returning complex objects by value is better than using out parameters, because returning by value is optimized since basically forever. Even prior to C++11 it's been optimized. But when you do need out parameters, you can use outputter proposal by Janhid Menid that is aimed for C++23. The authors are Janhid Menid, Todor Buyukliev, and Isabella Moete. This mainly is aimed at making C APIs easier to work with. This example demonstrates the feature pretty well. There's a DirectX graphics infrastructure interface function which enumerates adapters and takes a void pointer to pointer as an output parameter, and using outputter it becomes trivial to interface with it. You don't need to care about a lifetime of the returned pointer, and everything is handled automatically. So that would be a welcome feature for those who work a lot with C interfaces. While it's not in the standard, the implementation is proposed as a Boost library, and it's available right now on GitHub. Requires C++11. You can use it today if need be. I end on this photo I found on Twitter, and this is how software used to be distributed in the ancient days. This is a Sun Unix version 4.2 distribution, software release 0.4, dated 1983. Those were the days. And the last thing I wanted to show you today was this code snippet in JavaScript, because JavaScript is weird. When you execute this statement, print b plus a plus plus a plus a, and convert it to lowercase, you get a banana. And this works because the unary plus operation requires an argument that is a number. If it's not a number, it produces a string, not a number, which is NaN. If we join the characters, the resulting string from here and the characters and the character A, and lowercase it, we get a banana. JavaScript is weird indeed. That's it for today. Talk to you next week. Bye.